So in this part, we will start with EDA. So in EDA, we will see the data distribution, what kind of features we have, and what insights we can generate from data visualization. And then we can start with the pre-processing part. So EDA is nothing but a exploratory data analysis where we visualize the data using univariate analysis, bivariate analysis, and multivariate analysis. Okay. So first we'll do count plot, histogram plot of all the variable. So for that I'm using plt.subplot. So we have imported all the packages using import statement. So from Matplotlib only we will use plt. So plt.subplot will generate a multiple plots in same pane. So here I'm giving a figure size as 30, 20, 10. That means 20 will be the width and 10 will be the height. Subplots 3, 3 means 3 rows, 3 column. So in this way we will have 9 combination. Okay. So first I will create sns.countplot. Now here you need to notice this thing. I'm using plt.subplot to create a multiple section for the plot using Matplotlib library. But on each section I'm using SNS. SNS stands for Seaborn. So it's an alias name for Seaborn. So we are going to create a plot using Seaborn. So technically in this particular part, we are using Seaborn as well as Matplotlib, both the combination, so that we can create a good visualization with good customization. So plt.subplot 3, 3 means 3 into 3, 3 rows, 3 column, and the first column will be, first plot will be this count plot. On x-axis we will use gender, and data will be data frame, and axis will be ax 0, 0. So let's consider in this format. So we are using 3, 3. So I will have 3 columns and 3 rows. So this is first row, this is second row, and this is third row. So this 0, 0 indicate that we are going to plot this count plot using gender variable in this section. 0 for columns, 0 row and 0 column. Okay. Then next plot, histogram, and the axis will be 0, 1. So again 0 row, first column, then 0 row, second column. So here you can see 0, 2. So first 3 plot will go in the first row, then remaining 3 will go in the second row, and so on. So this is how we create a 3 by 3 combination plot using plt.subplot, and inside that we will create 9 plot using Seaborn. Okay. Now let's create count plot, and on x-axis we are going to use gender variable, data will be the data frame, and axis we have already declared 0, 0. Then we will create a histogram plot, and then again histogram plot, and then count plot. Now you need to notice why histogram and count plot. So count plot we use when we have categorical variable. So let's say gender is a categorical variable. So we can count how many male and females are present. That's why we are going to use count plot. Then age variable is a continuous variable. That's why we are going to use histogram. Sleep duration is again continuous variable. So we will use histogram. And whenever we use histogram, we need to mention the bins parameter as well. So here we are using bins 10. So based on your distribution, you can change this bins parameter. So 10, 20, 30, 40, up to you. But we don't have to set too high as well as too low. Okay. Then again count plot, histogram, count plot, histogram, just to identify the distribution of each and every variable. So let's execute this code. It will take couple of seconds. Yeah, now it's ready. Now how to read this code? See, so first plot is gender plot. Here we can see we have male and female. So male and female distribution is almost balanced. So we have male 175 candidate, and same female is also 175. Then in age we can see the distribution. So age with 45 number is high category, like high count. So people with 45H will be a highest in number. Sleep duration like 6.0, 6.5, 7.0, 7.5. So it is indicating the sleep duration. So there are few people who have sleep duration of somewhere around 6.8 or something like that. So but the count of those people are very less. Okay. Then we have quality of sleep. So if you increase the number 4, 5, 6, 7, 8, 9, that means quality of sleep is greater. So there are few people where quality of sleep is very less. You can see 4 and 5. Okay. And the count of those people are very less, like compared to, if you see on the x-axis, count is like roughly around 2 to 3, like that way. So majority of the people have a good quality sleep. We can see that 6, 7, 8, 9. Okay. Then physical activity. So we have a balance of physical activity, like there are few people who have very high physical activity and with low physical activity as well. Then stress level is almost same, kind of a uniform distribution. And then major part, quality, this one, BMI category. So we have overweight, normal and obese. So overweight is very high, normal is more than that, but obese is very less. So our sleep is also depend on our body weight. So obese means too high. So maybe those people who are obese, they may be struggling with the sleep disorder. Then daily step. So daily step is, again we have some numbers, and then the most important column is your dependent variable, sleep disorder. So here you can see we have 3 categories: none, sleep apnea means sleep apnea, and insomnia. So whenever you face any kind of classification problem, you need to make sure that your dependent variable is properly balanced. So in this case, we can clearly see that it is not properly balanced. We have none very high and sleep apnea and insomnia is low. So our model will be biased towards predicting the null value accurately rather than sleep disorder. So our class of importance is sleep apnea and insomnia. We need to predict whether the person has sleep disorder or not. So in this case, the data set is not balanced. So maybe our model will bias towards one category. So we need to make sure that thing. And whatever insights you generate from each plot, you can write that plot insights using this paragraph. Okay. Now let's go to the next part, gender and sleep disorder. Now here we will see whether gender will affect the sleep disorder or not. So for that I am using again count plot. On x-axis we will use gender, data will be my data frame, palette is HSL, palette is nothing but a color theme, and U is sleep disorder. So U is a categorical variable, and let's add the title. So let's see the part. Now see, so on left side, male side, we have many people who do not have any sleep disorder. So you can see this bar is very high, and on the female side we can see there are many females who have sleep disorder. Okay, so based on this plot we can conclude that like there are more number of females who have sleep disorder. Okay, so in female the disorder is present quietly high, but not in male. Okay, and if you compare, like the green part is sleep apnea, so female struggle with sleep apnea more compared to male, and for insomnia male struggles to sleep apnea, and there are few males who do not have any sleep disorder. Okay, now let's identify whether the occupation will affect the sleep disorder or not. So again we will use occupation and sleep disorder together. Okay. Now you can see for each particular on x-axis we have multiple occupation like software engineer, doctor, sales representative and all. So for every particular profession we can see individual bar for that particular category. So let's go to the first part, software engineer. So there are very less people who have sleep disorder. You can see a small green bar. But in doctor profession, there are many people who do not have sleep disorder. Okay. But if you go to nurse part, you can see there are multiple nurses who have struggle with sleep apnea, means waking up in between sleep. So because of this profession, they are facing this kind of disorder, sleep apnea. Then insomnia is teacher, like teacher and salesperson are facing insomnia issue. So this kind of insights you can generate from this plot. So based on this plot, we can conclude that occupation is very important role to detect whether the person will have sleep disorder or not. And same goes for gender. Okay. Then let's identify with BMI category. So I have picked only 3 like BMI, sleep, like occupation and gender, because based on the common sense. If you want, you can pick more category and you can combine that with sleep disorder column to identify whether this X particular value will affect the dependent variable or not. So let's use this BMI category. So again, we'll create a count plot. X BMI category, U equal to sleep disorder, data is my DF, palette is set1. Palette is nothing but theme. So now here you can see if the people are overweight, these people face more sleep apnea and insomnia. And if people are normal, then there is very less chance of having those sleep disorder. So many normal people do not have sleep disorder. So you can see this red color bar is very high. So if the person is normal fit, then the person the person will not have sleep disorder. But if you are an overweight, then there is a guarantee of having sleep disorder. And if you are obese, then it's sure shot. You will definitely have either sleep apnea or insomnia, because you can see there is no single person in obese category who do not have any sleep disorder. So again, our BMI category, profession, gender, all these parameters are important to predict whether a person has sleep disorder or not. Now let's move on to the data pre-processing part. So we have only 4 categories: gender, occupation, BMI category and sleep disorder. All these 4 categories are categorical variable, means which contain categorical values. So in machine learning model, we cannot directly pass those categorical values to the model. So we need to somehow convert this value into numbers. Okay. So I have created one variable vars, and inside this list I have mentioned all the categorical variable, and we will use label encoder to convert each category into number. So for example, in gender we have male female in text format. So using label encoder we will convert male female into 0, male into 1. Reason, female is alphabetically comes first and male comes later. So we will assign female equal to 0 and male equal to 1. So this is how label encoder works. So in gender, we will replace male female with 0, 1, and in occupation again 0, 1, 2, 3, 4, 5. In BMI category also we'll do the same thing. So what we have to do is, first we will write one for loop for I in variables, and then on top of that we will fit label encoder. But this label encoder you need to import. So from sklearn pre-processing, there is a function called label encoder. So from sklearn you need to import the pre-processing and create a label encoder object using this particular method. So once you create an label encoder object, then you can use this label encoder object inside this loop. So for I in variables, take one column and fit your label encoder on the data frame of that gender column. So let's consider in this way. So in iteration, the first column will be gender. So once you have the gender value, you can put that gender value inside the data frame. So from df.gender, it will extract all the unique values like male and female. Then label encoder will fit on male female. Then it will convert, means it will transform the same column like dfi into dfi. But instead of male female, it will return 0, 1. And here we can print the unique values from that column. And then in the second iteration, we'll do the same thing with occupation column. And then in third iteration, BMI category, and fourth iteration, we will process sleep disorder. So in this particular loop, we will take one individual column and we will convert that column into a numbers. So let's execute this thing. Okay, it's showing that name label encoder is not defined. That is because I have not imported this particular part. So let's first import this part. Now the label encoder has been imported properly. Now let's execute this part. Now you can see in gender, now we have 10. Occupation 91610520837 In BMI category, we have this number 201. And then in sleep disorder, we have 120. So now we have successfully converted the categorical column into numbers. Now let's see the data frame. So it should look like a proper numerical data frame. So if you run df.head, you can see 111, which indicates it's a male. Age, occupation, sleep duration, quality of sleep, all the categorical values are present in numerical format. Instead of head, you can also go with the tail part. So if I run df.tail, it will return the bottom 5 records of the same data frame. So again, it is showing all the numerical columns. Okay, we have sleep disorder 222. Okay, it is working proper. Now here you can see 2222, it is in a proper sequence. That means we need to shuffle the data set. Okay, otherwise the model will not generalize. So now we have done the pre-processing. Now let's identify whether any correlation is present in the data frame or not. So how to identify correlation? You can create a heat map. So again, we will use plt.figure and we'll set a plt.fix size. So I want to create a map plot with 20,16 size. And inside this heat map, first we need to calculate the df.correlation. So you can run the correlation like this as well, df.cor. So this df.correlation will give you the data frame with correlation value of all the columns, like gender into gender, age into age, and then age into gender, age into occupation, age into sleep duration. So it will create all possible combination of each and every variable, and based on that it will calculate the correlation value. Correlation indicate that how these two variables are behaving with each other. If one will increase, other will increase or decrease, like that way. Okay. So, but the thing is, we have around 12 independent variable. So it is very difficult to read this correlation data frame. So what we will do, we will pass this df.correlation inside this heat map, so that based on the color pattern, we can identify whether there is a high correlation or low correlation. So inside this df.heatmap, we will pass df.correlation function, which will calculate the correlation of each and every possible combination. And not equal to true means it will add the correlation value on that particular cell. Cmap indicate that color warm. Now if I execute this code, we will get the proper heat map. Okay. Now in this particular heat map, we won't able to identify the things properly, and also the size is very high. So we will shrink down to some lower value. Let's change the value to 1511 and then execute the code. This is little better. Now the thing is, if you see the range 1 minus 0.075, so it is not in a proper range. So whenever you create a correlation plot or heat map, you need to mention the min max value. So inside this heat map, I will add few more parameter. For example, Vmax equal to 1.0, comma, Vmin equal to minus 1.0. So correlation range is starting from +1 to -1. If the value is close to +1, means both the variable are correlated with each other. One will increase, other will increase in a rapid manner, because value is close to 1. Means high correlation. For example, if my salary in rupees will increase, then my salary in dollars will also increase. That means there are high correlation between Indian salary and salary in dollars, same. Now, if the value is close to negative, that means one will increase, other will decrease, inversely proportional. So Vmax, Vmin, here you need to mention the proper range for the correlation value. Now let's execute this code again. Now we have a proper color channel, -1 to +1 to -1. Now how to read this plot? So let's consider, so in this particular plot, you don't need to focus on this part. Okay, so this particular diagonal part you don't need to consider, because this is just a combination of same variable. Like take age on y-axis and take age on x-axis. Both the things are intersecting at this particular location. So the value is 1. So if you calculate the correlation of age variable with age, you will get 1 value. So you can directly ignore the diagonal value. Also, you can ignore the above part of the correlation plot because it's just a mirror image. So either consider the upper value of the diagonal or consider the lower value of the diagonal. So in this part, we need to see the color map, where the color is too dark or too light or in between color. So here you can see this part has very high value, 0.9, -0.9, means quality of sleep is indirectly proportional to stress level. Means this particular value, what we can identify, if the stress level is increasing, then quality of sleep is decreasing. And if the quality of sleep is increasing, then stress level will automatically decrease. So this value indicate that it's a inversely proportional. Now let's see one more value where the color is very high. This is also one part, -0.66. Again, it is related to heart rate. If quality of sleep increases, then heart rate will also decrease. So it is inversely proportional. So it is making sense that if you have a good quality of sleep, your stress level and heart rate will decrease. This is inversely proportional. Now let's see one more example, 0.88. Now this value is close to +1, means one will increase, other will increase. So sleep duration. If your sleep duration increase, then your quality of sleep will also increase. Again, this is making sense. So if you are sleeping more, your quality of sleep will increase. Then see one more value, this one, BMI category. So occupation. So if your occupation will increase, your body mass index will also increase. Again, this will make sense. If you get promoted or something like that, you will do less work and then body mass index will maybe increase. Then 61 and this is 59, age. So if your age is increasing, your systolic and diastolic blood pressure will also get increased. So that's why most of the senior citizen people after 50 or 60, they face blood pressure problem. So blood pressure is directly related to your age. So these kind of information you can extract from correlation plot using Heatmap. Now, if let's say if there are variables which are highly correlated with each other, for example, okay, let me plot this again. This one, 0.9, quality of sleep, stress level. Okay, so you can pick only one column, like instead of quality of sleep or stress level. But since we are, our main focus is deployment project, and this is the first iteration of the model building. So we will not drop any of the column even if the correlation is very high. Okay, now here you can see a highest correlation is systolic blood pressure, diastolic blood pressure, 0.97. This is the highest. So one will increase, other will also get increase. So this is the first iteration, and we don't know whether we should avoid the variables with high correlation or not, because in some case, if you drop those variables, then you may not get good accuracy, because even the correlation is very high, but still that particular variable may be very important feature for model prediction. So if you don't know what to do, just use all the variable at once. And after that, while reiterating to the model training, you can do little bit of like dropping few variables and training the model again. Then you can identify doing some R&D. So once we are done with the correlation part, then we will go for a data splitting. So in machine learning model, we generally split the data into the training and testing. So we will use this train test split function, and we will split the data into xtrain xtest, ytrain ytest. So these are the EDA part, pre-processing, data splitting part before model building. Now after this part, we will do the scaling and all, and then we'll start building the model.